Okay, now it's good to do a couple of problems like this. Like I said, this is going to be the most tedious thing you're going to do in this unit. And it's good to do it once or twice just to see exactly what the calculator is doing so you can see when the calculator or when the operator of the calculator does something silly and you get the wrong answer. Because like if you have some idea of how to do it by hand, then you're going to recognize when the calculator gives you an answer that anybody should figure out is wrong. Okay, so once again, here's our formula, and we have no idea what this formula means yet. All right? But we do see that there's a theme here, which is that, it's finding the difference between an x value and the mean value x. It's finding the difference between a y value and a mean y bar also. And it uses those values frequently. So it looks like it's really important to find x minus x bar and y minus y bar, because once you find it, you use it in several different places. After you find it, you multiply them together, you square them, you add them together, etc. Kind of a mess. And you can't do this with more than a few points, because more than a few points, you basically are going to have to use a computer anyway. And the idea is for you to do it without a calculator or a computer so that you can see what the heck is going on in the calculator. But if you use the calculator to figure out what's going on in the calculator, what's the point? Okay. So they give you fairly simple problems here. Let's take the first one, which is A. And I don't think you need to do A, B, and C. You could do like A and C. All right? Forget B. All right. Let's see, A. So we got a few points here. And I'm going to write it in an XY table here. The first point is 0, 1. Second point, 2, 2. Third point, 4, 3. Last point, 8, 5. All right. And then what I'm going to do, I am, of course, going to figure out what the average value is. So x bar. What is x bar? X bar is 8 plus 4 plus 2 plus 0, which is 12. It would be 14. And I'm going to divide 14 by 4 because I have 4 values. And so the average would be all of them added together and divided by 4. And guess what? I'm using a calculator to see what the calculator does. So x bar is equal to 3.5. Then I'm going to do the same thing with 1 plus 2 plus 3 plus 5, which is 11. And I'm going to divide 11 by the total number of values, which is 4, to get the average of y, which would be 2.75. Okay? Now that I have these averages, now I can figure out what x minus x bar is and what y minus y bar is, because by doing that, then I can fill in this table here. Okay? All right. So x minus x bar, that would be 0 minus 3.5, which would be negative 3.5. It would be 2 minus 3.5, which would be negative 1.5. It would be 4 minus 3.5, which is 4 minus 3.5, which would be 0.5, and 8 minus 3.5, which would be 4.5. What about the y? Y minus y bar would be 1 minus 2.75, which would be negative 1.75, 2 minus 2.75, which would be negative 1.75 also, 3 minus 2.75, which would be 0.25, and 5 minus 2.75, which would be 2.25. Okay, so now I have calculated the x minus x bar values for each coordinate pair and the y minus y bar values for each coordinate pair. What am I going to do with these? Okay, look at the summations here. I'm going to sum some things up to be the numerator and sum some things up to be the denominator, and it's kind of hard to see what this means, but if we do it one by one, it'll be not so bad. So we'll do x minus x bar. So x minus x bar times y minus y bar. So we're going to have a product here. Okay, so we're going to need to know x minus x bar times y minus y bar. And so I'm going to multiply each one of these together. Guess what? I'm going to use a calculator again. So to figure out what goes on in the TI-80 84 calculator, I'm going to need to use at least a simple calculator. Okay, if you're doing this on your internal assessment, you're going to have to do it as manually as possible to show the grader that you know what you're doing. And usually the way you do that, semi-manually, is to use the Excel on your computer, because then you can kind of break it up, just like I'm doing here. 0.5 times 0.25 is 0.125. 4.5 times 2.25, I can't do that in my head, 10.125. Okay, so now I got all the x minus x bar, y minus y bar products. And you can see what it says to do with those. It says to sigma them. Sigma means sum them. So I'm going to add all these up, and that's going to become my numerator. 6.125 plus 3.25 plus 0.125 plus 10.125. So the sum of all those is 19.625. Okay, so that actually is going to be the numerator of the R value for A. What about the denominator? Well, that's a real mess. We're going to square the X difference, and we're going to square the Y difference. We're going to add them all up. Once we add them all up, we're going to multiply them together, and then we're going to take the square root. Oh, man. Okay. What a mess. Okay, so I'm going to do x minus x bar squared, and I'm going to figure all those out, and then I'm going to sum those. And then I'm going to take y minus y bar squared, and I'm going to sum all those. And then I'm going to multiply the two sums together, and then we're going to take the square root. So, okay. Let's see, what are we doing first? We're going to look at negative 3.5, and we're going to square it. So actually, when we square 3.5, we don't need to use the negative because the negatives go away, right? So this one's going to be 12.25. Okay, what about 1.5 squared? Negative 1.5 times negative 1.5, it's positive 2.25. The negative signs go away again. 0.5 times 0.5 would be 0.25. And 4.5 times 4.5 is 20.25. Okay, and then to add all those up, I just need to use a calculator again. I'm sure using the calculator a lot to figure out what goes on in the calculator. Okay, the total is 35. Who knows if all these are right? I do the same thing with y minus y bar. And so, for example, negative 1.75 squared is equal to 3.0625. And so it's 3.0625. 3.0625. And the next one is also negative 1.75 squared. 3.0625. Don't need to do that in the calculator again. Then 0.25 squared. 0.25 squared is 0.0625. Last of all, 2.25 squared, which is 5.0625. Okay, now I'm going to add all these up. They're all positive numbers, of course. Are you surprised by that? No, because we're not surprised because we squared all these numbers, so of course they are positive. And I just did something wrong because I didn't get the right answer. I just got a really long decimal, and I know that would be wrong. Okay, 11.25, that sounds better. Okay, so now I have, let's mark what I have up here. I'm gonna mark using green all the components I have. So I have sigma x minus x bar, y minus y bar. It is here, right? I multiplied each x minus x bar times each y minus y bar, and I added them all together. Okay? Now I'm going to do this one in orange. It's 35, right? Because I took all my x minus x bars, squared them, and then I added them together. Now, this part is here, 11.25, because I took all my y minus y bar and squared them and added them together. And finally, I'm going to multiply the yellow times the orange, and I'm going to get 3093.75. And that's the yellow times the orange. And then I'm going to square root it. And I'm going to get 19.84. So the answer to the R value is going to be the green, which is 19.625, divided by 19.84, which is pretty good, meaning it's a number that is close to 1. It's 0.989. Positive 0.989. So it's a positive correlation. It's very close to 1, so it's a strong correlation. And it looks like a strong correlation too, right? So that's a 0.989 right there. Okay? I think that's good. You get the idea. If you do this one, you're going to get a negative R, of course. It'll be close to 1 also. What about this one? This one is not going to give you a really big number because it doesn't look like a line, does it? It looks like a square to me. So it's going to be something closer to 0. Okay? All right, let's move on to number 3. Okay, now number 3, it's only got 5 points. We can figure this, calculate the correlation coefficient by hand, just like we did last time. So let's try to do that again. First thing we're going to do is we're going to draw a scatter diagram. What we're showing is the ages of 5 children and the number of times they visit the doctor to see if maybe when they get older they visit the doctor less or something like that. Okay? So on the x-axis we're going to have the numbers between 2 and 8, which is, let's see, 2 and 10. And on the y-axis, we're going to have the numbers pretty much up to 10 also. Okay, so 10 and 5. All right, and we're going to graph these points. So we're going to have 2 comma 10. There's 1. We have 5 comma 6. 5 comma 6. There's 1. 7 comma 5. There it is. 5 comma 4. There it is. 8 comma 3. There it is. Okay. Does that look linear? Kind of. I mean, it's a line that's kind of going down. Okay. Now calculate the correlation coefficient by hand. All right. Let's see. So remember, R equals that big mess, right? And the most important thing is we need to find x minus x bar and y minus y bar. And then we need to start combining it in certain ways like we did in the previous problem, remember? So the first thing we need to figure out is what's x bar, what's y bar, and to do that, remember, we just add up all the numbers. 2 plus 5 plus 7 plus 5 plus 8, and we get 27, and we divide it by the total number of numbers, which is 5, and we get 5.4. So x bar is 5.4. What about y bar? What's y bar? So we'll do 10 plus 6 plus 5 plus 4 plus 3. And we get 28, and we divide that by 5, and that gives us 5.6. So those are our x bar and our y bar. And we're going to use x bar and y bar to subtract from the original x's. So for example, the first x minus x bar value is 2 minus 5.4, which is negative 3.4. And the first y value is y minus y bar value is 10 minus 5.6, which is 4.4. Okay, and so we go on like that. So 5 minus 5.4 is negative 0.4. 6 minus 5.6 is 0.4. 7 minus 5.4 is 2.6. 5 minus 5.6 is negative 0.6. 5 minus 5.4 is negative 0.4. 4 minus 4.6 is negative 1.6. And 8 minus 5.4 is 2.6. That's weird. I got 2.6 for the 7 too. Oh, this should be 1.6, right? Made a mistake. That's 1.6. Do one by hand. I got the wrong answer. And then 3 minus 5.6, which would be negative 2.6. Okay, so now we have all of our x minus x bar values. We have all of our y minus y bar values. What's the next thing we calculated? The next thing we calculated was the x minus x bar times the y minus y bar factor. So we're going to do x minus x bar times y minus y bar. And so we're just multiplying these two together. And of course, I'm going to have to use the calculator. So for the first one, I get negative 14.96. And the next one, I get negative 0.16. You see I'm getting a negative because one of them is negative, one of them is positive. This next one is going to be negative 0.96. Next one is 0.4 times 1.6. 0.64. Last one, 2.6 times 2.6. Negative 6.76. Okay. So that's what I get for multiplying x minus x bar times y minus y bar, which is going to be used in the R equation, right? Or the R formula. Now I'm going to need the x minus x bar squared value and the y minus y bar squared value. So the x minus x bar squared value and the y minus y bar squared value. Okay, so let's see. 3.4 squared, and the negative sign is going to go away, is 11.56. 4.4 squared is 19.36. No negative sign because it's positive. 0.4 squared is 0.16, and negative sign, of course, goes away. This one is also 0.4 squared. 1.6 squared is 2.56. 0.6 squared is 0.36, and the negative sign, of course, goes away. 0.4 squared is again 0.16. 1.6 squared is 3.136. All positive, of course, because negatives multiplied times themselves become positive also. And the last one is also. Same stuff. Okay. Now, we do want to add up all of our x minus x bar times y minus y bars. All right, so we're going to add up this column. 14.96, which is a negative number, plus 0.16, which is also a negative number, plus 0.96, which is also a negative number, and plus 6.76, which is also a negative number. So we have this negative number, and we're going to subtract this negative number times the positive number 0.64. You'll find that the answer is going to be negative 22.2. All right? And then we're going to add up these two columns also, which are, thank goodness, all positive numbers. 11.56 plus 0.16 plus 2.56 plus 0.16 plus 6.76 equals 21.2. And the last column, 19.36 plus 0.16 plus 0.36, 3.136, and 6.76. 29.776. 29.776. Okay, now we're going to use the R formula. And the R formula tells us on the numerator we need x we need x minus x bar times y minus y bar, and we're going to sum them all up. And that's exactly what we did there. So we're going to put the green part on top. Then we're going to take the orange part, which is x minus x bar squared all summed up, which is that number there. And then we're going to get the yellow part, which is all the y minus y bar squared summed up, which is that part there. And that's going to go there. Orange is going to go here. And then finally, we're going to divide them both, and we're going to put them under with the root sign in the bottom. Okay, that's the formula for R. So green is negative 22.2. X minus x bar is 21.2. And y minus y bar squared all added up is 29.776. So now let's see, 29.76 times 21.2, both positive, of course. Take the square root of that. We get 25.12 in the denominator. We got negative 22.2 in the numerator. And our result is negative 0.884. Okay, that's our R value. Whew. Okay, and it says to check your answer using technology. I'll show you how to do that now. Okay, describe the correlation between age and number of doctor's visits. It is negative, linear, and is it strong? I don't remember. Let's go back and look at yesterday or the previous page. If we have negative 0.884, it would be that classification. So, oh, no, negative 0.884 would be there, not there. So it would be moderate negative. No, strong negative. Strong negative. So we would classify this as negative linear strong or strong negative linear. Okay, and then they say to check your answer on the calculator. Let me show you how to do one of these on the calculator. All right. The way you do it on the calculator is you press Stat and Edit. And let's clear these out. The way you clear these out is you just do Clear, Enter. And then it just deletes the whole list. Don't do delete because that really deletes the list. It'll delete the L1 from your calculator and you have to do something special to get it back. So first we're going to put all the X values in the left column. So we're going to put 2, 5, 7, 5, 8. And then the Y values in the right column is 10, 6, 5, 10, 6, 5, 4, 3. Okay, and then we're going to do a stat, calc, linreg. And this might not do it because we might not have turned on diagnostics in a while. No, it didn't do it. So we need to turn on diagnostics and go back and do this again. The way you turn on diagnostics on your calculator, if you haven't done it already, is you do the catalog command, which is the second 0, and then you go down to the D's. You can go down to the D's quickly by pressing green D. For some reason, you have to type it twice. And then we go to diagnostic on. Diagnostic on. Click Enter. Enter. And now we can go back and do the stat calc linreg again. And this time, now that we have diagnostic mode on, and notice L1 and L2 are in the X list and the Y list because that's where we put our X and Y numbers. There we go. R is negative 0.892. And they got a slightly different answer, didn't they? Okay, weird. I'm just going to check one more time. My data, 25758, 10, 6, 5, 4, 3. Okay. Pretty easy to make a stupid mistake here somewhere, and I'm going to check that real quick. Hold on. Okay, I figured out where the mistake was. To figure out where the mistake was, of course, I had to use a computer and Excel, but here. This was wrong here. 0.64 squared is actually 2.56. So because that was wrong, everything else was slightly wrong. This added up together was supposed to be 29.2. So the yellow one is 29.2, not 29.77. 29.2. And as a result, we get exactly what the calculator should give us, which is negative 0.892. Okay? Ooh, so it is not easy to do this by hand, even with only 5 points. And when you do the last one, thank goodness it doesn't ask you to do it by hand. It just says for you to calculate it by R. So if we are going to calculate this one by R, we are going to do it with the calculator. So let's do that. So again, all you need to do is type in these two lists into list 1 and list 2. And the way you clear them out, remember, is you go up, put the cursor on the list, and you type clear. And then you go down, and then you do that on both. And now they're empty. So now we're going to go down and we'll put in list 1, 25, 22, 15, 19, etc. In list 2, we're going to put 9, 7, 4, 8, etc. And just hold on, and I'll do that for you right now. And if you want to follow along with your calculator, pause, and you can do that too. Now, it says draw a scatter diagram for this data. By the way, I put in all the data here. Okay. Draw a scatter diagram for this data. We can do the first few points together, and then you can go ahead and finish on your own. But like the biggest data for the X list here, this is X and this is Y, the biggest X value is 29, right? So let's say we're going to do 10, 20, 30. Okay? And then for the Y values, it goes up to 10. So we'll go up to 10. So the first value is 25, 9. So 25, 9. So that would be there. And the second value is 22, 7, which would be there. And then do the rest on your own, and we'll come back after I'm done with all these, okay? Okay, so we're back. I graphed all these points. There's this little cloud here now, which is part A. Now we're going to calculate R, and the way we do that is we do stat, calc, linreg, and as you remember, we've already turned on our diagnostic, so when we do this, it's going to come out together with this screen. So the R value is 0.776, which is pretty good. I don't think it's strong, but it's like moderate. Describe the correlation between ticket sales and beverage sales. Let's go back and look at the table, see what 0.776 corresponds to. 0.776 corresponds to positive, moderate correlation. So that's what we're going to put here. We are going to write it's positive, linear, moderate correlation. Okay? All right. Finally, we're done with this page. Now, these other two, like these two here, you could do this with the calculator just by typing these numbers in with the calculator. You don't have to do them by hand. I think 2 problems done by hand is enough. Okay?